again, we have one other property to learn. One other. Now, it's really easy. However, if you're not careful, you can make mistakes, and you know I make them all the time. But we're still looking at the worksheet 5.4.6. I need you all to really, really pay attention. So let's look at example 1. Example 1, where you see a triangle. Okay, but what else should you notice? This is what I want you to know. It tells you that segment ST is tangent to circle Q. All right, so this is a tangent. But we don't have two tangents in this case. We have one tangent. So what do we do with this? This is one rule I want you to always remember. Notice that at point S. Point S is the point of tangency. But it's also something else. It is also an endpoint for one of the radii of that circle. So this is a radius. Anytime a radius and a tangent segment meet at the point of tangency, they are perpendicular to each other. They're always perpendicular. So they meet, they form a right angle. So once again, anytime you have a radius to intersect a tangent segment at its point of tangency, when they intersect, they form a right angle. So we really have a right triangle. And we also have some measures given for the size of those triangles, for the triangle. However, they want us to solve for R. When this is the case, you can always apply Pythagorean theorem. And this is what we want to use, Pythagorean. You know Pythagorean theorem. It is a squared plus b squared is equal to c squared. And of course, A and B represent the measures for the legs, and C is the measure for the hypotenuse. What are the legs? The legs are the two sides that meet to form the right angle. So now let's plug these measures into the equation where they need to go. Beginning with the legs. One of the legs is represented by R, so we plug in R squared plus, and the other leg is represented by 48, 48 squared. And we set that equal to the measure for the hypotenuse. Oh, wait a minute, be careful. For the hypotenuse, we have this part is represented by R, and then from here to here is 36. So to represent the measure for this whole segment, we got to add R plus 36. So it's R plus 36, but we also need to square it. So you want to write that expression within parentheses. So we have our equation set up, let's solve it. To solve this, let's begin on the left side. Let's bring down R squared plus, take your calculators and square 48. We get 2,304. But how do we square this binomial? We box it. So we find some scratch paper and we form a box, and let's apply the box method. We want to multiply R plus 36 times R plus 36. We get R squared. Here we get 36R. Here we get 36R. But for this box, we need to square 36. So 36 times 36 is 1,296. And now let's bring this trinomial over here to the problem. So we want to write R squared plus 36 plus 36, I believe, is 72. So that's 72R plus 1,296. Now let's simplify the equation. The first term I would deal with would be the quadratics. So let's move R squared. To move R squared, I need to subtract R squared. So you do that to both sides. Notice what happened. The quadratic terms cancel. So that leaves 2,304 equal to 72 times R plus 1,296. For the number on the side by itself, leave it. It's fine. Do we have something like it over here on the other side? We do. The 1,296. So we want to move it over here to the left side with this like term. So how do we undo it? Minus 1,296. So your algebra skills need to be together, guys. So this cancels, but what is 2,304 minus 1,296? I got 1,008. And then we bring down the 72 times R. Now let's divide each side by 72. and we find that R is 14. It worked out. R is 14. Are there any questions? All right. But if you go to problem 2 and it says find the value of x, wait a minute. I have one tangent here. I have another tangent. Here we have two tangents that meet at a common external point. If that's the case, then you should be thinking, oh, even though we have some right angles, still we should be looking at the concept that the tangents are congruent. They are congruent. So this segment is equal in measure to this segment. So to solve this equation, we set these two expressions equal. X squared is equal to 16. Take the square root of both sides. So x is equal to both the positive and negative of 4. Can we use both the positive and negative 4 in this case? Yes, we can, because we're squaring an x. If you square a negative, you get a positive. If you square a positive, you get a positive. So therefore, both the positive and negative will work for this particular problem. Let's look at 3. Give you another example of working with a triangle. And see, can you do one of these on your own? For problem 3, and we all need to be working and taking very good notes. You might want to do this work on another sheet of paper. Just put the number of this worksheet on it as well. Okay, so once again, we have a tangent, but we only have one tangent. We have a tangent that meets our radius, the intersect or radius of the circle at the point of tangency. So when they intersect, they form this right angle. We have a right triangle. We have measures for all 3 sides, but we have some variables involved. And we need to solve for the variable value. So we want to plug it, once again, into Pythagorean theorem. So we want to use a squared plus b squared is equal to c squared. Let's place the measures where they need to go. For one leg, we have r squared plus, for the other leg, 28 squared equal to, but to get the measure for the hypotenuse, we need to add this part plus that part. So that's r plus 14. Place this expression within parentheses and squared. So now let's simplify what we have. All right, so we bring down r squared. We had 48 earlier, let's square 28. 28 squared is 784, but for the binomial, we need to box it. So let's find some space somewhere and form a box and find this product. R squared, 14r, 14r, and 14 squared is 196. Now let's bring this back up to the problem. R squared, if we combine these two here, we get plus 28r plus the 196. Let's isolate r. Begin with your quadratic. So let's move the r squared. So we're going to subtract r squared from both sides. When we do this, we eliminate the quadratic terms. So that we bring down 784 on the left. And on the right, we bring down what we have given. Let me erase this. Well, as I erase this, I want you to keep working. Can you complete this without my help? That's very important. All right, so I bring down the 28r plus the 196. Leave the number on the side by itself where it is. Which one of these terms is like it? Then move it over here with it. The 196. So cancel it out by subtracting 196 from both sides of the equation. So 784 minus 196 leaves 588. Excuse me. The 196 is canceled, now leaves 28 times r. You know the deal. If we divide each side by 28, we have the solution for r. So divide by 28, and that leaves 21. We're through. It may take a lot of room, but hey, it's okay. So I want to do one more example with you, and I need you to go home and practice working these problems. So let's flip to the back, and let's all try the top. Now 1 through 3 at the top are easy. They're really simple. They only gave you one measure for your hypotenuse. So you plug that one measure in. I will not do the whole problem, but if I look at number 1 on the back with you for the practice, they're very simple. Don't feel like you got to have 2 parts because I did those other 2 with 2 parts. In this case, it's simpler for you. So once again, we have one tangent, but we have a right triangle, And so we have a measure for the hypotenuse, we have a measure for one of the legs, but we got to solve for the measure of the other leg. So once again, we'll do a squared plus b squared is equal to c squared. One leg is your variable x, the other is 96, equal to the hypotenuse. But in this case, the whole hypotenuse is represented by 100. To solve this, we're going to move 96 squared. So x squared equals, I say this, what is 100 squared minus 96 squared? And guess what? You can put it in the calculator just like you have it written on your paper. So 100 squared minus 96 squared. That gives me 784. Okay? So now we want to take the square root of this. And we get 28. That was simple. Problems 2 and 3 works the same way. However, when you go to the bottom and look at problems 7 through 8, what about problem 7? How do you work it? I'll do one more example, and then I will go and let you guys try some of your own. Now in this case, your hypotenuse has two parts, 2 and r, okay? But still, you have one tangent. You have one tangent to the circle that intersects a radius at the point of tangency, so we have a right triangle. We want to solve for r, so we will need to plug into the Pythagorean theorem. A squared plus b squared equals c squared. Alright, so these are the legs that meet to form the right angle. One is represented by r, the other is represented by 4. So plug in those measures and set that equal to the hypotenuse. But to get the hypotenuse, we're going to combine r with 2. So 2 plus r squared. Bring down the r squared. 4 squared is 16. But what is r plus 2 squared? Box it. You can do this really quickly. R squared, 2r, 2r, 4. Alright, so we bring this over as r squared plus 4r plus 4. Let's move the quadratic terms. Subtract r squared from both sides. That leaves 16 equals, on the other side, 4r plus 4. Subtract 4. That leaves 12 is equal to 4 times r. Divide by 4. Really simple. So you have two other properties to deal with. When you have two tangents drawn to a circle from a common external point, the two tangents are congruent. Set their measures equal. Or if you have a tangent drawn to a circle, but it intersects the circle at an endpoint of a radius, they are perpendicular, they form a right angle, you can apply Pythagorean theorem to solve for the measure of a side, or the measure of the variable. So go home, work some of these problems out, you work some of the ones we did in class, come back tomorrow with these concepts, because you come in, you need to have your homework completed. I'll give you probably a copy of my key so you can check your work, and then you guys will take a quiz. It should take about 30 minutes in class to complete it. So be ready so you can leave when the bell sounds to go to your next class. All right, see you next week.